Okay, so we have an electron that started out from far away, where the electric potential is 0 volt, and therefore it started out with 0 electric potential energy. These two spheres are positively charged, so the electron will feel an attraction, and it will accelerate and it will pass through between the two spheres. The question asks for the minimum speed at which the electron can cross this line. So for that, we got to study the electric potential along this line here. From the graph given in figure 7.2, we can tell that the potential is maximum on the surface of sphere A, 835 volts, and it decreases until it reaches a minimum of 295 volts, and then it climbs back a bit to 390 volts at sphere B. The crucial thing to note is that this is an electron, so it has a negative charge. So the higher the potential, the lower the EPE. For example, the potential here is the highest, but if the electron is found here, it actually has the lowest EPE of negative 835 electron volt. So here is actually the highest electric potential, but for an electron, this is where it has the highest EPE of negative 295 electron volt. So going from here to here actually corresponds to the electron losing the least amount of EPE, which will correspond to the least gain in KE. So I repeat, going from here to here compared to going from any other points is actually the least amount of loss in EPE, which should translate to the least amount of gain in KE, which should translate to the minimum speed. Alright, so now we know to cross the line with the minimum speed, it should cross at the point where the potential is 295 volt. Let's move on to the calculation. So of course it's going to involve a principle of conservation of energy, and there are two ways to set up our equations. I'll briefly run through the pros and cons of each approach. The first approach is the gain equals to loss approach. The second approach is the initial equals to final approach. The troublesome thing about this approach is you got to figure out who gains and who loses. That's the troublesome bit. But once you have figured that out, the good thing is when you figure out the change in EPE, all you have to do is to put in the magnitudes. So you don't care whether this is a negative charge or positive charge, you just put in the magnitude of the charge. You don't care whether the potential difference is positive or negative, you just put in a positive number. Okay? The second approach here, the easy thing about this second approach is you just put down initial equals to final. You don't have to figure out gain or loss or whatever. But the only thing you've got to be careful about this approach is when you calculate the EPE, you must not forget about the sign. You must include the sign of the charge, and you must include the sign of the potential. Obviously, both approaches, if done correctly, should lead to the same correct answer. Personally, I prefer this one, the second approach, but for very simple questions, this could actually be faster. For example, for this one, this could actually be faster. But for more complicated situations, usually this one leads to less confusion. Okay, that's all. Ta-ta!